Welcome back, Mr. Sam's Maths channel. This is question 9, part C, which kind of stopped. Part B stopped kind of abruptly at the end. I thought that this part C was attached to that, but for some reason it wasn't. So anyway, this is part C of that question from January 2022 from the Pure Mathematics P4 International A-Level Edexcel paper. Question A and B were about this equation. Question A was setting up the differential equation. Question B was solving it and finding the general solution to the differential equation, which I've just put up here at the top here. That was the differential equation that we solved to find the general solution, which was this. This was the general solution for this differential equation. A general solution means getting rid of the dy dx. That's what it means. So we had to integrate both sides with respect to x and rearrange the variables and then integrate with respect to whatever on each side and get this answer. We ended up with this answer. Now they're asking us for the particular solution. Now to find the particular solution, sometimes I actually use limits from the original setup of the differential equation, and I just use those limits to find the value of c. But in this case, I think because we already have got the general solution anyway, which with the plus c part, which was part of what we had to do for part B, then it's easier for us to just proceed as just taking this and saying, okay, when x equals pi over 6, we know y equals 1, so we can substitute these values in and find the unknown c for that particular point, and then we can find what c is. So we got 3 over 1 plus 2 times the ln of 1, and that's squared, equals 2 times the cosine of 2 times pi over 6, which is pi over 3, plus c. Alright, so now we want to find what c is here. So we got 3 over, and you have 1 plus 2 times 0. So that's 1 squared, which is 1, so that's going to be 3. And you got 2 times cosine pi over 3. Now pi over 3, cosine of pi over 3 is like the cosine of 60, which is a half. So that's 2 times a half plus c. So it's 3 equals 1 plus c. So therefore we can say c is equal to 3 minus 1, which is 2. So c is equal to 2. So now we have our particular solution is 1 plus 2 ln y squared equals 2 cosine 2x plus 2. But we want to write it in this form. That's why I've just copied this here. That's the form that we want to write it in. Okay, so we have to think about how to get this into that form. Now what I can see is, first of all, I have here a secant of a single angle x, and I have a cosine of a double angle 2x. I know cosine and secant are reciprocal of each other. That's no problem, but that's a single angle, that's a double angle. So the first thing I'm going to do is rewrite cosine 2x as a single angle using the double angle formula. Now we should know that cosine 2x is equal to 2 cosine squared x minus 1. In case you forget, let's go back to the origin of cosine a plus a, or cosine x plus x will be cosine x times cosine x minus sine x times sine x, which is cosine squared x minus sine squared x. That's from the compound angle formulae, or the additional formulae. And I know that sine squared x is 1 minus cosine squared x. So I've got cosine squared x minus, and then I have in brackets 1 minus cosine squared x again. So I have cosine squared x minus cosine squared x, which is 2 cosine squared x minus 1. So I can replace this cosine 2x with 2 cosine squared x minus 1. Then I got my plus 2 outside. On this side of the equation I got 3 over 1 plus 2 times ln of y, and that's all squared. Now if I expand this, I have 3 over 1 plus 2 times the ln of y all squared equals, this is 4 cosine squared x minus 2. Then I got the plus 2 outside the bracket, they cancel out. So now I'm getting somewhere, I think. Let's now rearrange this. I want to make y the subject, so let me just write this. So I've got this whole thing on the numerator there, and this I'll just like cross multiply basically. So I have 4 cosine squared x equals 1 plus 2 ln of y squared. Now I can get rid of this square by taking the square root of both sides. So if I take the square root of both sides, okay, take the square root of both sides, then I'm going to have here root 3 over 2 times cosine x, okay, is equal to, and this is going to be 1 plus 2 ln y. Taking the square root of both sides. Now I know that 2 cosine x, or root 3 over cosine x, is the same as root 3 times secant x. So this is like root 3 over 2 times secant x. This is the reciprocal of cosine x is secant x. So I can write that in the numerator as secant x equals 1 plus 2 ln y. So we're getting a bit closer now. We want to make y the subject. Let me subtract 1 from both sides. If I subtract 1 from both sides, I have root 3 over 2 times secant x minus 1 equals 2 ln y. And now if I take it to the next page, the next step, I can divide this all by 2. So let me just take this to the next page. Okay, so now I want to make y the subject. Let me divide both sides by 2. So I have root 3 over 4 times secant x minus a half equals ln y. And now I can just use the laws of logarithms. I know that the log to the base a of b equals c can be written as a to the power of c equals b. This is the base, this is the power, this is the result. So I can think of this as log to the base e of y equals whatever is here. So it's e to the power of all of this is equal to y. So I can say y equals e to the power of all of this, okay, which is 3/4, or root 3, sorry, over 4 times secant x minus a half. And there's the answer. And we can see here that it's in the right form, and our a therefore is root 3 over 4. But we have to just write it in this form, so that's fine as our answer. So there's the answer to question number 9. So it's just a bit of algebraic manipulation that we had to go through to get to this final step here. So basically, first of all, what we did is we found the value of c using our integral from the last part of the question, and then we tried to make y the subject of this. Okay, so we tried to make y the subject of this, and the key to that was the fact that we have cosine of 2x, and we want to end up with secant of x. A double angle has to become a single angle, so I use a double angle formula to change it from cosine 2x into something involving cosine x. And then we know that secant and cosine are basically reciprocals of each other. So once we got to this stage here, we could take the square root and then write it in terms of its reciprocal. So it's a bit of an involved question. You have to always keep sight of your goal. Okay, always. That's why I kept copying this and putting this in the next stages down, so we could see what we're trying to aim to make y the subject with the secant x there. All right, so there's the answer to part C of this question. Other parts of this question I will put on a link to in the end of this video. That will link you to part A and B of the question over here. Over here you'll have a link to the rest of the paper of January 2022 P4, and you over here questions to do with differential equations in general you'll find in this particular playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.